Okay, now that we've seen how to do a more complicated, more involved redox reaction using the oxidation numbers and the arrow method together, let's see how easy it would be to balance this using the half reaction method. We're going to use the same steps as whenever we did the simple redox, but there's a few additional steps involved. We're going to separate it in half reactions. We're going to balance the atoms, but not the oxygens or the hydrogens. Then we're going to add water to balance the oxygen, but only if we need to. And we're going to add hydrogen ions to balance the hydrogen if we need. And then we're going to add electrons to balance the charge. Now it's really important that you recognize that at this point, this is the same whether we do acidic or basic solution. Now, if the solution is in acidic medium, like this one is, H pluses, then you just proceed down to step number 7. But if not, you got 2 additional steps. If you're in basic solution, if this had an OH minus instead of an H plus in the reaction, we have to add hydroxides to both sides enough to neutralize the H plus. And remember that H plus plus OH minus makes H2O. And then the results of that neutralization is that it allows us to cancel out any extra waters. Once you're there, then you go back to the regular steps, which is multiply each of the half reactions by whatever factor you need so that the electrons cancel out. It's the same for both. Then we add the 2 half reactions together. Alright, let's see how easy this is. The 2 half reactions here are Cr2O7 minus 2 going to Cr plus 3. Let's just do that one, shall we? I think we might run out of room a little bit, so let's just go through. There's 1 of these for every 2 of those. Good. Now, we add waters to balance the oxygen. There's 7 waters on that side, so we have to add 7 H2Os. Now we have to add hydrogen ion, H plus, to balance the hydrogens. Don't we need 14 H pluses on this side? Right? So now we have chromium's balanced, oxygen's balanced, and H is balanced. So now what? Electrons to balance the charge. We got a plus 6 on the right and a plus 12 on the left. If we're plus 12 on the left and plus 6 on the right, you have to add 6 electrons on the left to get it to balance. So this half reaction looks like 1Cr2O7 minus 2 plus 14H plus 1s plus 6 electrons goes to 2Cr plus 3s plus 7 waters. Okay? Good. Now let's balance the other half reaction. The other half reaction goes like this. Vanadium goes to, well, let's move it over. Underline that. Okay, vanadium goes to VO2 plus 1. Basically, we don't worry about the H pluses in the waters. That gets taken care of just in the balancing process. It's a 1-to-1 ratio for these guys, 1 vanadium to 1 vanadium. We'll have to add 2 waters to balance the oxygen, and then 4 H pluses to balance the hydrogen. Now we have to balance the charge. This is 0 on this side, 0 plus 0. And this is plus 1 and plus 4 or plus 5, so we need to add 5 electrons here. That's that balanced half reaction. That's that balanced half reaction. Got 6 electrons, 5 electrons. You can see where we have to multiply here by 6, multiply here by 5 to get it to balance out. So let's add all those together, multiply them out. That's 5 dichromate ion minus 2 plus 5 times 14. What the heck is 5 times 14? Is 70H plus 30 electrons goes to 5 times 2 is 10 Cr plus 3 plus 35 waters. Okay, and then down here we've got 6 times 2 or 12 waters plus 6 vanadiums goes to 24H plus 30 electrons. So what gets to cancel out here to make our addition subtraction a little easier? 30 electrons go. If we have 70H pluses on the left and 24H pluses on the right, what's 70 minus 24? 765, that's 46 H pluses on the left. If we have 35 waters over here and 12 waters over here, that leaves us with 23 waters on this side, right? Adding together 5 Cr2O7 minus 2s plus 6 vanadiums plus 46 H pluses goes to 10 Cr plus 3s I forgot to add something, didn't I? Forgot to add the 6 VO2 plus 1s plus 6 VO2 plus 1 plus 23 waters. Okay, guess what? 5, 6, 46H plus is 10, 6, 23 waters. 5, 6, 46H pluses, 10, 6, 23 waters. Exactly the same answer. No surprise. Same stuff. Same business. You tell me which one you like better. I know which one I like better. I like the arrow method. I just almost made a mistake right there by forgetting about the 6 VO2 plus 1s that are on that right hand side. It's just so easy to make mistakes. I find this more complicated, and this is one of the easy ones. We didn't even have to neutralize by adding hydroxide ions. So you do it whichever way you think that you can do best, most efficiently, and most correctly. We'll try a basic solution next for both methods. See what you think. Practice up. Good luck.